In this video, I'll be helping you with the ALEKS problem type called Introduction to Partial Fraction Decomposition with Distinct Linear Factors. And for partial fraction decomposition, we can think of this as sort of moving backwards to separate a fraction into its pieces. And since our denominators here have two factors, x minus 1 and x plus 1, I can say that this fraction can be deconstructed to be some number which I'll call a over the first factor, x minus 1, plus some other number that I'll call b over x plus 4. So you can see that the right-hand side is essentially the addition that we would have prior to getting a common denominator, and then simplifying to get this expression. And we'll just need to find a and b to write this right-hand side as two fractions being added. So I'll start by rewriting. We know that the partial fraction decomposition on the right-hand side is going to be equal to the left-hand side. To start to solve for a and b, I would like to start by getting rid of all of these fractions. And you may recall from earlier that we can do that by multiplying both the left and right-hand side by the lowest common denominator. And for all of these fractions, the lowest common denominator is going to be x minus 1 times x plus 4. So I will multiply the left-hand side by x minus 1, x plus 4. Since the right-hand side has two terms, each one will get multiplied by x minus 1, x plus 4. And from here, all of these fractions will cancel, leaving me with just 5x on the left-hand side. And on the right-hand side, we also have the x minus 1's cancel, leaving me a times x plus 4. And then the x plus 4's cancel, leaving me with b times x minus 1. And recall, our goal here is to solve for a and b. To continue solving, I can pick specific values of x to plug in, but strategically so that either the a or b will cancel. So for example, if I plug in x equals 1, then this factor will become 0, eliminating the b. To show what that looks like, if I say x equals 1, then 5 times x, 5 times 1 is 5, equals a times, if x is 1, then that would be 1 plus 4, which is 5, plus b times 1 minus 1. 1 minus 1 is 0, so this is just b times 0. The b times 0 has completely eliminated b, and I have 5 equals 5 times a, so I know that a equals 1. Using that same strategy again, but this time instead of canceling out the term with the b, I'll cancel out the term with the a by letting x equal a negative 4. This will zero out this factor, giving me on the left-hand side 5 times negative 4 is negative 20. We have a times negative 4 plus 4 is 0, plus b times negative 4 minus 1 is negative 5. So here we can see the a's have canceled. Negative 20 equals negative 5b. So solving for b, we have b is negative 20 divided by negative 5, or a positive 4. So we have our a, which is 1, and our b, which is 4. Looking back at where we started, we've identified a and b as 1 and 4. So our partial fraction decomposition has a as 1 over x minus 1, plus b, which is 4, over x plus 4. We've completed the partial fraction decomposition. And again, if we were to get a common denominator here and combine these two fractions with addition, that would get us back to where we started prior to the partial fraction decomposition.